At this site, we have a power line operating at 230,000 volts with the telephone pedestal almost directly underneath. This voltage level produces an extremely high electrical field, often referred to as an E field. If we point an FVD toward the line, we get an immediate alarm. If you test this technician, you will find that he is energized. These indications are caused by the electrical field between the power line and nearby conductive objects. These are not false indications. The indicated voltage does exist on the objects. The voltage is coupled through a very small amount of capacitance and at a low frequency, so there also exists a very large amount of opposition to the coupling. To us, this means there is almost no capability to produce damaging current flow, so the observed voltages are not dangerous. They are also very easy to remove. Watch what happens to the indication on my partner when we connect him to a simple ESD wrist strap that is grounded. The same thing happens when he contacts anything that is conductive and goes into the earth. This same phenomena will give an apparent false indication when we test a grounded object, such as this pedestal, if the operator is not grounded. The best way to overcome this is for the operator to ground himself by any safe means at his disposal and test the pedestal or cabinet. Here is a case of capacitive coupling that many telephone technicians will recognize. There are two C-wire runs. One is terminated, the other is unterminated or floating. Now, notice the indications when we test each with the FVD. The floating C-wire appears energized, while the other is not. In this situation, the floating C-wire is capacitively coupled to AC power over the length of the run. You should avoid contact with this C-wire. This coupling can give a shock strong enough to cause one to fall or otherwise injure oneself. It is recommended that a visual inspection of the route be made to determine that no physical hazards exist. After this has been determined, to make the situation safe, simply connect the floating C-wire to a temporary ground. Always retest with the FVD after the ground is placed. And remember to follow your company's safety policy when placing or removing temporary or permanent grounds. When working aloft, an operator can make use of the shielding effect of the cable or strand being tested. As seen earlier, a grounded conductor will shield an operator from being coupled to an electrical field. Keeping this in mind, you would always approach the cable or strand to be tested from below. That way, the cable or strand itself will serve as a shield for the operator, avoiding the false indication that could otherwise occur. There is often confusion over induction, power contact or partial contact, capacitive or E-field coupling, and ground coupling. Partial contact and ground coupling are similar and should be treated the same. If the voltage is at a hazardous level, either one can be dangerous. Inductive coupling occurs because of the magnetic field that surrounds a current-carrying conductor. It should be noted that this is the method used to produce electric power and to drive electric motors. The ability of induced voltages to produce current flow is then obvious, so it should be treated the same as contact and ground coupling. Capacitive coupling is different. Some AC will couple across any capacitance, as we saw at the site under the 230 kilovolt line. However, current flow through this capacitance varies directly with the amount of capacitance present and the operating frequency. At 60 Hertz, the frequency is low and capacitance is very low, so current flow must also be extremely low. Capacitive coupling at 60 Hertz then should not be considered a hazard. A condition can exist whereby large currents can flow while voltages are quite low. As long as this condition persists, it is not hazardous. If, however, this circuit is opened so that the current flow stops, the voltage on one side of the open can immediately reach dangerous levels. Always treat potential high current situations as hazardous. Always look for indications of high current, such as discoloration, excessive heating, smoke, etc. Test current-carrying conductors with the FVD before making any contact with them. Always follow your company's safety policy when placing or removing temporary or permanent bonds. When testing a device that is cyclic in nature, such as a traffic light support strand, the operator should always test through at least one complete cycle. This will avoid missing detection of a fault that occurs on a single phase of the cycle. In summary, the FVD has been designed to overcome many of the limitations of previous test sets. The small size and ease of operation make it a very useful tool. However, no tool can be of value if it is not used. Keep the FVD with you and use it at every opportunity you have.